In this video, we're learning how to multiply rational expressions. And if you look at the first example, we have these two fractions here that we're going to multiply that each have some variables in them. So when we're multiplying fractions that have variable expressions, we are going to multiply in a similar way that we do when we're multiplying just numbers. So remember, if we're just multiplying two fractions together that have numbers, we just want to multiply the numerators and multiply the denominators, but we want to try and cross-reduce if possible. So that's what we want to do here first. So luckily these two fractions are both completely factored. Their numerators and denominators are both written in factored form. So what we're going to do is cross-cancel or cross-reduce any common factors that we see on the numerator of one fraction and the denominator of another. So you may notice that the top left fraction has an x minus 3 as a factor on the numerator, and the bottom of the right fraction has an x minus 3. So we can cross these out. So remember, when you're cross-reducing, you can reduce any common factor in the numerator of one fraction and the denominator of another fraction. This only works when you are multiplying fractions. So we're going to cross out those two factors, and you also may notice that there's an x plus 5 in the denominator of the first fraction and an x plus 5 in the numerator of the second. So we are going to cross those out, and now we're just going to multiply straight across. We can't cancel anything else out. So on the top, we have x times x plus 2. And on the bottom, we just have x plus 4. There's nothing else left. And I'm just going to leave it in factored form. So we get x times x plus 2 over x plus 4 as our answer. Now let's go through two examples where we actually have to factor before we do the multiplication. So for example 2, we're multiplying two fractions, but they are not factored. So what we want to start by doing is factoring the numerator and denominator of each fraction. So I'm going to go ahead and do that over here on the right. So let's start by factoring the numerator of the left fraction. So we have 5x squared minus 125. What we want to start by doing is pulling out what they have in common. So 5x squared and negative 125 can both be divided by 5. So we're going to pull a 5 out. 5x squared divided by 5 is going to leave us with an x squared. And negative 125 divided by 5 is going to leave us with a negative 25. And now we're going to factor the denominator of the left fraction. So we have 2x minus 8. So we can pull out a 2. And if we do that, we're going to be left with x minus 4. And now we want to do the same thing for the right fraction. So let's start by factoring this numerator of x squared minus x minus 12. So we need two numbers that multiply to negative 12 that add to negative 1. And if you take a second and think about that, we should get negative 4 and positive 3. So we're going to have x minus 4 times x plus 3. And now we want to factor the denominator, so we can take an x out of x squared and positive 5x. So I'm going to pull an x out, and we're going to be left with x plus 5. And now we can still factor this x squared minus 25 a little bit more because it's the difference of two squares. So we're going to go ahead and do that over here on the left. So I'm going to keep the 5. And now we have to factor x squared minus 25, which is the difference of two squares because x squared is a perfect square and so is 25. So what we want to do is take the square root of the first term, so the square root of x squared, which is x. We're going to put that in the first spot in each parentheses. We're going to take the square root of 25, which is 5, put that in the second spot. We're going to put a plus in between one of the parentheses and a minus in the other parentheses. The rest of our problem is fully factored, so I'm just going to recopy it down here, and then we'll start crossing things out. So we have x minus 4 times x plus 3 over x times x plus 5, and we're going to see if we can cross cancel or just reduce anything. So we have an x plus 5 on the top left fraction. So we're going to cross this out over here. We have an x plus 5 on the bottom of our right fraction, so we can cross those out. And we have an x minus 4 on the bottom of the left fraction and the top of the right fraction, so we're also going to cross those out. So now on the top, we are left with a 5 times an x minus 5 times an x plus 3. And on the bottom, we are just left with a 2 times x, and we can't cancel out anything else. So this is what we get as our final answer. Let's go through one more example. So for this last example, again, these are not in factored form, so we're going to have to start by factoring them, and I encourage you guys to pause the video for this example and try it on your own, and then you can watch me work through it to make sure that you've done it correctly. So let's start by factoring the top of the left fraction, and I'm actually going to do it over here on the right because it's going to take a few steps. So I'm going to factor 2p cubed plus 5p squared plus 6p plus 15 over here. And because we have 4 terms, we're going to have to factor by grouping. So what we want to do first is factor 2p cubed plus 5p squared by pulling out what they have in common. And they can both be divided by a p squared. If we divide 2p cubed by p squared, we're left with 2p. And if we divide 5p squared by p squared, we are left with a positive 5. We're going to do the same thing for plus 6p plus 15. So we can divide them both by a positive 3. So we're going to pull out a positive 3. 6p divided by positive 3 leaves us with a 2p. 15 divided by 3 is going to leave us with a positive 5. And now these two factors should be the same. And the way we're going to write our answer is we're going to write the factor that shows up twice, so 2p plus 5, and we're going to multiply that by the two terms on the outside added together, so p squared plus 3. So now we know that the numerator of our leftmost fraction factors into 2p plus 5 times p squared plus 3. And now let's factor the denominator of the left fraction. So this is the difference of 2 squares. So let's set up our two parentheses. In the first spot in our parentheses, we're going to take the square root of p squared, which is p. So we're going to put p in both of the first spots. And then we want to take the square root of 64, which is 8. We're going to put that in the second spot, put a plus in one of the parentheses and a minus in the other. And now we want to factor the numerator of our right fraction. So we have p squared plus 5p minus 24. So we need two numbers that multiply to negative 24 that add to positive 5. Take a second and think about that. And we should get positive 8 and negative 3. So this is going to factor to p plus 8 times p minus 3. And now to factor the denominator, it's going to take a little bit more space, so I'm going to do it over here on the right again. So we have 2p squared minus p minus 15. Because we have a 2 in front of our p squared, we don't just have a 1, I'm going to use what's called the x method to factor this. So I'm going to draw an x to organize my work. On the top of my x, I'm going to put a times c. So 2 times negative 15 is negative 30. And on the bottom of my x, I'm going to put my b term. Since we have negative p, our b term is negative 1. We need two numbers that multiply to negative 30 and add to negative 1. And if we think about that, we should get negative 6 and positive 5. And now we're going to split our middle term into two terms that have coefficients of negative 6 and positive 5. So 2p squared minus 6p plus 5p minus 15. And now we're going to factor by grouping just like we did for the numerator of the left fraction. So we're going to pull out what 2p squared and negative 6p have in common, and that's going to be a 2p. And we're going to be left with p minus 3. We're going to pull out what 5p minus 15 have in common, and we always want to pull out the sign of the leftmost term. So we're going to take out a positive 5, and we're going to be left with p minus 3. And then we're just going to write our answer. So we're going to get p minus 3 times 2p plus 5. So we'll go ahead and write that in the denominator of our second fraction. So p minus 3 times 2p plus 5. And now let's see if we could cross reduce. So the numerator of our left fraction has a 2p plus 5, and the denominator of our right fraction has a 2p plus 5, so we can cross those out. The denominator of our first fraction has a p plus 8, and the numerator of our second fraction has a p plus 8, so we can cross those out. And then don't forget to actually just check if you can reduce either of the fractions, not cross reduce, but just reduce. So you may notice in the right fraction, we have a p minus 3 on the top and a p minus 3 on the bottom, so we can cross those out. And then when we multiply across, we're only left with this p squared plus 3 in the numerator of our first fraction, and this p minus 8 in the denominator of our first fraction. Everything else in the second fraction just canceled out to 1. So we get p squared plus 3 over p minus 8 as our final answer. So hopefully this video helped you guys understand how to multiply rational expressions. If you want some more practice with similar problems, check out the link in our description for a free practice worksheet.